This is day 3 on multiplying rational expressions. However, today we're also going to be dividing some rational expressions. So let's take a look at the first problem here. We've got a rational expression where we have an x squared or an n squared term, and we have another n, but this is only going to have common factors. It's not going to factor as two binomials. And so when you look at one, look for common factors first. So the first thing I'm going to do is I'm going to take out the common factor of 6n. So I know 6 goes into 18, and they both have at least one n. So I'm going to divide each of those terms by 6n. So 6n goes on the outside of the parenthesis. I do some division. 6 divided by 6 makes 1. N squared over n makes n. And then over here, 18 divided by 6 makes 3. N divided by n, well, those cancel out. So that's the factored form there. So always look for common factors and take those out. And then once you get to this form here, there's no more common factors, you're done. Well, down below it's an n squared, but this one has no common factors. N squared, 9n, 8. So this is going to factor as two binomials. And so when I go ahead and do that, I've got n times n makes the n squared. 8 times 1 makes 8, and I'll put two plus signs because those two numbers need to add to make 9n, which it does. Well, over here I'm going to take a look at the top of the fraction, and I see no common factors. However, it's a binomial, and both are perfect squares. So that's going to factor as a difference of two squares. So we'll have n minus 1 and n plus 1. So this is a difference of two squares. It factors to a sum, like I have here, and a difference, because negative 1, 1 multiply to make the negative 1. They subtract to make 0. That's why you don't see that middle term. Well, here you see how we have 2n and 6. Well, there's a common factor. So when there's common factors, take out that common factor, like 2, put it on the outside of a parenthesis, and then do some division. See how those 2's will cancel? So we're just left with n. 6 divided by 2 makes 3. So now we can go ahead and start looking for some canceling. So when we do that, look at the top of the fraction. Think of this as like one big fraction bar here. And now look at the top. So you see how the n plus 3's? They're the same. And so we can go ahead and cancel those. See that n plus 1? Well, those are the same also, so we can cancel those. And then look at the 2 and the 6. See, 2 goes into 6 3 times, so I was able to reduce that. But that's as far as we can go. See, there's no other n down here to cancel out this n on top. No n minus 1 here, no n plus 8 up on top. So we can go ahead and just rewrite what we've got. And so we've got a 3 times by n multiplied by an n minus 1. That's on top of the fraction. Down below we just have an n plus 8. And that's it. That's as far as I'm going to take the problem. You could end up multiplying out the numerator, and if you did, you'd end up with a 3n squared minus 3n, but it'd still be over n plus 8. Either answer is fine. So the next one, same sort of thing. We're looking for common factors. But I don't see any on top, so I can go ahead and factor it as two binomials. And so it's going to factor to x minus 10 and an x plus 10. And then down below, here's where I see a common factor. You see 5 and 50? 5 goes into each of those numbers. So I'm going to divide by 5, put the 5 on the outside, and then do some division. So let's see what's left over when I do the division. 5x over 5, well, the 5's cancel out, leaving me with x. 50 divided by 5 makes 10. And then up on top we've got the 5 and an x minus 10. No factoring here because you see there's no common factors. It doesn't factor as two binomials. So what we do from this point is we look for common factors. Again, treat this as one big fraction. So I'm going to bring that fraction bar across and then look for the canceling. Well, x minus 10 and an x minus 10 here, so I'll put parentheses around this. Those will cancel. The x plus 10's cancel, and the 5's cancel. Everything canceled. Common mistake is people want to say the answer is 0, but that's not the case. It's 1, because you see when things cancel, you're left with 1. 1 times a number doesn't change anything, so our answer is just 1. Well, looking at the next one here, we've got a trinomial on top. So it's going to factor as two binomials. So we've got an x plus 1 and another x plus 1. See, 1 times 1 makes 1, and they add to make 2. So that's the way it ends up factoring. Down below, we've got a x squared minus 49. So that's going to factor as two binomials. x minus 7 and an x plus 7. And then we're going to multiply. Down up on top, we've got an x squared minus 8x plus 7. So notice that they have to multiply to make 7, but add to make negative 8. So I know both signs are negative, and the only numbers that multiply to make 7 are negative 1 times negative 7. We multiply to make that positive 7, add to make that negative 8x. Another difference of squares, so when you see two binomials, and one is an x squared and one's another perfect square, so they're both perfect squares, that means it's a difference of squares. And a difference of squares factors to a sum, like this, x plus 1, and a difference, x minus 1. See, negative 1, 1 multiply to make negative 1, and they add to make 0. So now we've got it all factored, so we can start canceling. So again, extend that fraction bar, and then look for the same factors on top and bottom, like the x plus 1's there, and I have the x minus 1's. Again, notice that there are two x plus 1's, but I can only cancel one set out. And then I cannot cancel this other x plus 1 unless there was another x plus 1 somewhere down here. But there was not. Here the x minus 7 cancels this x minus 7. So all I have left is that x plus 1 on top, and I've got the x plus 7 down below. Well, let's take a look at our next one. These next three problems are division problems. And so when we do these, we're looking to see, first of all, if there's common factors in factoring, but then at the end we've got one extra step. So let's get to the factoring first. This is the same as the one up top for number 1. There's a common factor of 6, but then also an x. So let's pull out that 6x. Always take out that common factor. So 6x goes on the outside. I've got an x minus 3. Left over when I do that division. Here I've got 12x squared. See, I have a big number here. See, they both have at least two x's. This one has 2, this one has 3. So I'm going to pull out the 12x squared here. So 12x squared goes on the outside, and I do the division. I've got an x plus 1. See, I've got only one x left here. The 12x squared over 12x squared just leaves me with 1. Now it's a division problem, so we're going to rewrite that division sign. And then factor here, I've got x squared minus 9, and except I want to factor that. I want to factor that to a binomial, two binomials, so it's going to be x minus 3 and an x plus 3. And then from there down below, I've got another trinomial, which will end up factoring as two binomials, and it's going to factor to an x plus 3 and an x plus 1. And so from this point, we've got a division problem. So what we can do is we can multiply by the reciprocal. So I'm going to change that division to multiplication. And here's what we change. It's on this side of the fraction. This first one did not change, but this one does. So notice that the x plus 3 and the x plus 1, I'm putting those on top of the fraction. And I'm putting the x minus 3, and I'm putting that x plus 3 on the bottom of the fraction. So notice, this is what changed. I brought this down below and this up top. That's the only part that changes. And so I'm going to rewrite the rest of the stuff. I've got a 6x, and I've got the x minus 3. Notice this does not change. This stays the same. 12x squared, and I've got the x plus 1. And so from this point, now we can do some canceling. So we've got again, treat this as one big fraction bar now. And look for the common factors. I see x minus 3's, those cancel. X plus 3's, x plus 1's, and here I've got a x that's going to cancel out one of the x's down below, and I got the 6 goes into this 12 two times. So everything canceled out on top. So if everything cancels, you still have a number. That number is 1. So we have to make sure we rewrite that number. So let's rewrite what we've got all together here. We've got a 1 on top, and we've got 2x on the bottom. And that is our answer. Well, this next one, again, what we could have done, instead of factoring first, we could just go ahead and take the reciprocal first. So let's do that this time. Let's go ahead and move this fraction here. Since it's a division problem, we're going to move that down below. I'm going to take this 16x, I'm going to move that on top. And that's the only part that will change. We take the reciprocal of the divisor of the second fraction. And then the division sign is going to become multiplication. So let's go ahead and rewrite what we've got. We've got this x squared minus 9 over x squared plus 6x plus 9. And now we're multiplying by 16x over 4x squared minus 12x. So now we can go ahead and do some factoring, and I see that that top of the fraction, that first one's a difference of squares. So it's going to factor to an x minus 3 and an x plus 3. And then down below it's a trinomial, and that's going to factor to an x plus 3 multiplied by another x plus 3. So they needed to multiply to make 9 and add to make 6. So we're multiplying by 16x. So that's already factored. We can't do anything with that. But this one here has some common factors. I see 4 goes into each of these numbers and x. So I'm going to pull out a 4x, do some division, and I've got an x minus 3 left over. Notice how the 4's cancel. X squared over x just makes an x. 12 divided by 4 makes the 3. X's cancel out. And so now we've got it set up. Now we can go ahead and do some canceling. Again, treat this as one big fraction now. And then from there, we're going to go ahead and do the reducing. So I see that x minus 3 will cancel out this x minus 3. This x plus 3 will take out this x plus 3. But notice that I cannot take this x plus 3 out, only one at a time. Well, this x will cancel out this x, and 4 goes into 16 4 times. So let's see what's left over. So sometimes it's nice when you've canceled a lot of stuff to circle what's left over. So notice how I have a 4 here, and I have the x plus 3. So that's all I've got left over. And so that's what I'm going to write down. 4 over x plus 3. And there is my answer. Well, taking a look at the next one, what's different about this one is that you don't see any addition signs. It's all multiplication. So what we can do is take the reciprocal first. Let's go ahead and do that. We'll move the top of the fraction down below, bottom up top. And then I'll go ahead and rewrite what I've got. So I'm going to rewrite this 6x squared y to the 5th over 5x. We're now multiplying by 3x. Notice the 3x goes on top. And notice it changes to a multiplication sign as well. And then we get the 4x to the 3rd, y to the 3rd on the bottom of the fraction. And so from this point, I can go ahead and rewrite this as one big fraction. Now when I do that, I'm going to start combining some terms. I'm using the commutative property. So the commutative property allows us to move terms around as long as all we're doing is multiplying or adding. So this is the commutative property of multiplication. So I'm going to take the 6, take the 3, bring those together, count up the number of x's. So I got 2 x's and 1 x makes 3 x's, so x to the 3rd. And then count up those y's, well, it's just those 5. Down below, the same thing, 5 and 4, bring those next to each other. And then count up the x's. You got 1x and 3 x's make 4 x's. And then count up the y's. You just got those 3 y's. And so now we can go ahead and do some reducing. So let's go ahead and cancel out some numbers here. See, these 3 x's will cancel out 3 of the x's down below. So all I've got is 1x left over. These 3 y's will cancel out 3 of the y's down below, or up top, leaving me with 2 y's left over. Well, here I have a common factor. I see 3 and 5 have nothing in common, but 6 and 4 do. See, they each can be divided by 2. So that's what I'm going to do. I'm dividing each by 2. So this becomes a 2 here, and divide this by 2, and this becomes a 3. But that's it. You see 3 and 3, 5 and 2, no common factors. So let's see what's left over. Again, here's a good time to circle some terms to see what's left over. You got 3 and a 3, so that makes 9. So I got 9 there. And then no more x's here, but I've got these 2 y's right here. And so I got 9y squared. Down below, I've got a 5 and a 2 that need to be multiplied, so that makes 10. And then I just have this x to the first power. Notice how all the y's are gone, so just x. And there's our answer. So those are the types of problems you'll end up seeing on tonight's homework. Good luck.